Okay, so today we're going to be talking about vertical asymptotes. So, asymptotes are this weird thing, and sometimes people try to oversimplify them and actually say things that aren't quite true about asymptotes. So, we're going to talk about what it means to be an asymptote, and then in particular, we're talking about vertical asymptotes in this video. We're going to talk about some of the other asymptotes in other videos. So, an asymptote happens. They happen, well, let's say vertical. Let's stick with vertical. We'll do all vertical in this video. So vertical asymptotes happen when y gets really close to infinity as x gets close to a number. Okay, so how do we read this? This says y approaches infinity. This little arrow in math means approaches, and it means just like what it means in English, as our y values on a graph. Of course, the y values are these ones. Okay, so the up and down values. If the y values are getting really big and they keep getting bigger and they keep getting bigger and they're getting closer and closer and closer to the number infinity, which of course isn't really a number, right? It's more like an idea. It's this list of numbers, maybe, because every number that you give me, I could give you a bigger number. So we never can actually reach infinity. We can only approach infinity, right? So as I get further and further up here on the graph, x is getting close to a particular number. So in other words, it doesn't keep going like a lot of the graphs that we work with, like this graph, parabola, right? As x gets bigger, so does y. They're both getting close to infinity. As we go this way on the x's, we're also going this way on the y's. Or you can think about it as we're going this way on the y's, we're also going this way on the x's. And so x and y are both getting close to infinity. But this is a different situation. X is going to get close to a number, and I'm going to show you what I mean in a second if it seems like you don't really know. Now, the other thing that could be true that could create a vertical asymptote is this one. As y gets close to negative infinity, x is going to get close to a number. And you can kind of think about it the other way if it makes it easier. As x gets close to a number, y is going to get close to negative infinity. And as x gets close to a number, y is going to get close to infinity. That's probably the way we would normally think about it because we're going to be putting x's in and finding y's. But this is what we're talking about. Y has to be getting either ginormously big or ginormously small, meaning way, way, way up in this graph or way, 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 way down on the graph, and x is getting close to a particular number, okay? Now, we're going to be talking about rational functions, so we're going to use this rational function to talk about it. Now, this is called a rational function because, of course, he's a ratio. He's a fraction because ratio in math means, fraction. It's comparing numbers using division. So this is a rational function. It's a fraction. Okay? So let's think about this for a second. Now, we talked about excluded values before, and we said that excluded values were values that I cannot plug into this function because it would make this function undefined. And hopefully everybody here is looking at this one and knows that the number I can't plug into here is 0, right? X cannot equal 0 here. And why? Because that would mean we're dividing 1 by 0, and you can't divide 1 into no pieces, or we talked about how division is the multiplying by the reciprocal, and since 0 doesn't have a reciprocal, you can't divide by 0, right? So in other words, 0 is our excluded value, and in some cases, that just means that you can't use the number 0, but in this case, it's going to create this weird thing called a vertical asymptote, close to where x is equal to 0. So let's take a look at it for a second. Okay, let's say that we take this function and we let x be a number close to 0. So we know that we can't put a 0 in there, but let's put a number close to 0. So let's say like 0.1. Okay, so this guy would be 1 over 0.1. What kind of number would that be? Well, 1 divided by 1/10. What kind of number is that? Yeah, of course it's 10, right? So that would be a 10. So this is going to be equal to 10. What if I did divided by So we're getting numbers that are closer to 0. Do you see that? I'm getting smaller numbers, so these numbers are getting closer to 0. But this number, what is that one now? 1 divided by 100th is, of course, 100, right? And we could keep doing this. We could keep putting more and more zeros here. Like, let's just put a lot. 1, 2, 3, 4, 5, 6. Right? So what does that mean? 1 over this. Well, what number is that? That's going to be a really big number. It's going to be a 1 with 1, 2, 3, 4, 5, 6, 7 zeros after it. Right? It's a really big number. And what's going to happen is I put more zeros in here. This number is actually going to be getting bigger and bigger and bigger and bigger. So think about it for a second. If I were trying to graph this function, let's take a look at it. Let me just move a little bit of this stuff out of the way so I can move my paper up. Okay, so we're going to be graphing this one. And whenever we don't know what a function looks like, we can always just make a table of values. And so some of these are easy, right? When I put in a 0, that we said we can't, right? Not allowed. So this one is not allowed. But if I put in a 1, what am I going to get? I'm going to get a 1. If I put in a -1, I'll get a -1, because 1 over -1. If I put in a 2, what do I get? A half. If I put in a -2, what do I get? A -1/2. And hopefully you can see, I'm keep getting these fraction things are going to happen, right? So when I put in a 1, I get a 1. When I put in a 2, I get a 1/2. When I put in a 3, I get a 1/3. I can't put in a 0, but take a look at what happens when I start using these numbers that are between 1 and 0. So all of these numbers are between 1 and 0, aren't they? Of course they are, right? If I put in a half in here, actually, what number do I get? I actually get a 2. And when I put a 1/3 in there, what do I get? A 3. Do you see that? Because we're dividing by 1/2, which means multiply by 2. So as I come in here at a half, we're actually going to be up here at 2. At a third, we're going to be up here at 3. And then as I get really close to 0, when I'm at a 10th, I'm way up here at 10. And when I'm here at 100th, I'm way up here at 100. And when I'm, this number, I'm way, 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 way off the screen. I'm way, way close to infinity. I'm getting really, really huge. So what ends up happening is, as I start putting these numbers in that are close to 0, my outputs, my y's, get really, really huge, right? So when I put in a 1/10, I got a 10. When I put in 100th, I got 100, didn't I? That's what was happening in each of those cases. So that's what's happening here. This is creating an asymptote. Now this value starts to look like it's getting closer and closer and close to 0 because the x values are getting closer and closer and closer to 0. I'm putting these smaller and smaller fractions. So we're getting closer and closer to the y-axis, but I actually don't ever reach the y-axis. But my y's are going crazy. So you see here, as x approaches a number, and in this case, x is approaching 0, so this is as x approaches 0, remember this little arrow means approaches, y is approaching infinity. That means it's an asymptote. Okay? Which is different than this picture where x and y were both getting really big or close to infinity. That's a different situation, right? This one, x is getting really, really close to 0 while y is the only one getting really, really big. Okay. So what happens on this other side when we start using these negative numbers now? When I did -1, I got a -1. A -2 gave me a -1/2. And a -3 gave me a -3/3. And what's going to happen between here and here? Well, again, if I stick negatives in front of these numbers, if I put in, I'm going to make another table here because you can't see it otherwise. Can you see that one? A little bit. Okay, so if I put this here, if I put in a -10, that gives me a -1/10, which is going to be like here. It's getting, -10. It's going to be closer to the x-axis here, right? I'm sorry, I'm doing the over here. When I do negative, what did I want to do? Oh yeah, negative 10 will be a negative 1/10, but that's not what I wanted to show you. I wanted to show you negative 1/10 will give me a negative 10. So that will be like way down here, right? A negative 100th will give me a negative 100. That's still true. That is true. It's going to be way up here, but way, 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 way down, right? And so the smaller the fraction I put in, the bigger the number. Because when you have a small number on the bottom of the fraction, that means you have a really, really big number, right? When you divide by a little teeny tiny number, you're actually getting a really big number. And so this is what our function looks like. And what's going to happen here is this line, this vertical line, my pen doesn't write very well, this vertical line here is called my vertical asymptote. Because y gets really big as x gets close to this value. And what is my vertical asymptote? It's the line x is equal to 0. And isn't that what a vertical, how we describe a vertical line? X is equal to something. So my vertical asymptote is x is equal to 0. And this is actually what my parent graph looks like for my rational functions. This guy right here. He's my very, very basic rational function, so we call him the parent. And this is what his graph looks like. Okay? Now, how do we find these vertical asymptotes for other rational functions that are, a little more complicated? Well, the same way. Let's take a look at another one. Okay? So the first thing that I want to do here is find my excluded values. Just like I did here. I looked at this one and I said my excluded value was 0 because I can't stick a 0 in here. I'll make it undefined. What would my excluded values be here? So how do you find excluded values? You set this thing equal to 0 and see what number you get, right? So you get x is equal to 3. So 3 is my excluded value. In other words, x cannot equal 3 in this example. Okay? Does everyone agree with that? X cannot equal 3. It's my excluded value. There's only one excluded value. It's 3. Okay? So again, what happens when we make our table of values? Well, let's think about it for a second. If I put in a 0, I get a negative 1/3. If I put in a 1, like all those numbers are okay, right? When I put in a 1, I actually get a negative 1/2. When I put in a 2, I actually get a negative 1. But I can't put in 3 because that's a no-no, right? That one doesn't work. But let's see what happens when I put numbers that are close to 0. So for instance, let's put in 3.01. 3.01. So I put in 3.01 for x, and I get 1 over, which is again what number? That's actually 100, isn't it? Now let's say x is equal to 3.001. What's going to happen here? Of course, we're going to subtract the 3's, and we're going to have this number again. And now this is 1,000, right? So what's happening here is I'm getting closer to this excluded value. My fraction is actually getting closer and closer to this really huge number, or in other words, infinity. And it would actually work if I did it the other way. If I pick a number on the other side of 3, so if I picked like 2.9, right? If I did 1 over 2.9 minus 3, that would actually give me a negative 0.1. So that would be a negative 10. But if I picked x is equal to 2.99, well, what's this one going to be? This one's going to be 1 over 2.99 minus 3. So that's going to be 1 over negative, or in other words, negative 100. And what's going to happen is, as I keep putting more 9s here or getting closer to 3, this number is going to start, I'm going to keep adding zeros to this. And we're going to keep getting that number that's way, 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 way down on my graph. Does that make sense? So what's going to happen here is this guy is going to look like this one. I'm going to put a break at -3 because that's the value I know I can't plug into my function. So I know there's some kind of break here. I can't have anything there at -3 because that would make this guy undefined. I'm sorry, this guy undefined. I'll write it here. And of course, we just said as we get close to 3 on this side of 3, so to the right of 3 on this side, or to the left of 3, excuse me, on this side of 3, what happens is we're going to start getting these bigger and bigger and bigger values. We're going to keep getting closer to 3, right? Because this is closer to 3 than this one. If I keep adding 9s and getting closer. But what will happen is the output, when I plug it into this function, will actually be a little teeny tiny number. And what's going to happen on this side of 3, well, as I put numbers in, they're going to get really, really, really big. I'm going to keep getting closer to 3 this way, right? But this number is going to keep going up. So when I put the positives in, I'm going to keep getting these big positive numbers. And then what's going to happen if I put like whole numbers in here, right? If I put a 4, well, that'll be 1 over, that'll be a 1, right? If I put a 5, that'll be a 1/2, right? And if I put a 6, that'll be a 1/3. You see what's happening now over here? This starts to go down like this again. And the same thing we just saw is going to happen on this side. We're going to keep getting closer to 0 here, but I actually will never get out of 0 of this, because in order to get a 0 out of a fraction, what part of the fraction has to be a 0? So this is a very important thing to remember. It helps if you remember this. In order for a fraction to be equal to 0, the numerator, this right, like a crazy person, the numerator, or in other words, the top, must be 0. Right? Because that's the only way to get a 0 out of a fraction. You need the top to be 0. You can't have 0 on the bottom. So the only way to get it is to have 0 on the top. Well, this fraction will never have 0 on the top, which means the y value will never be 0. And that's what this picture shows. I keep getting closer to 0, right? These fractions keep getting closer to 0, or these fractions keep getting closer to 0 on this side, but they never actually are going to be 0. And my y's are getting really, really big and really, really small. So x is getting, as x gets closer and closer to this value of 3, y is going to be getting closer and closer to infinity. Okay, and this is what makes a vertical asymptote. So in essence, what do you do to really find vertical asymptotes? Well, it's kind of, you can kind of sum it up, right? So my vertical asymptote here, I already know is going to be the line x is equal to -2. Now, do you know how I knew that? I knew that because if I put a 2 in here, a -2 in here, I would get a 0. Which means as I put numbers close to -2 in here, the bottom of the fraction is going to be really tiny. And that means you're going to have a really big number for y. And so my vertical asymptote is this. So how did I figure it out? I really figured out what was going to be equal to, what was going to make the denominator equal to 0. And that's really how you can find vertical asymptotes. There's only one trick, okay? Now this is the one thing you have to be careful of. So to find, I'll write it down even, find vertical asymptotes. If you can read my writing. To find vertical asymptotes, find where the denominator is 0. Okay, now there's only one thing that you have to be careful of, and it's something like this. Now there's 2 places in this denominator where you could have make this be a 0. So in this case, my 2 excluded values are going to be x cannot equal -2, just like in this one. But x can also not equal -3. Okay, but take a look. If I were to reduce this fraction, do you see that? I just canceled out those x plus 2's. This function and this function kind of look the same, because this function, and if I multiply it by x plus 2 over x plus 2, which is what number? This is the number 1, right? What happens when you multiply by the number 1? You get back what you started with. Do you see what I'm talking about here? So this and this are the same, except, remember when we were doing our multiplying and dividing and simplifying and stuff, we always had to go back to the original one to find the excluded values. This and this are actually the same thing, except this one, we eliminated one of the excluded values. So if you can reduce it out, so cross it out like this one, these are both excluded values. But only x plus, or I guess only -3 is creating an asymptote. And I'll show you why. If we have 1 over x plus 3, does everyone see what we're doing? I'm just thinking about it this way, right? And let's say I put numbers close to 2 in here. Let's say I put on a 1.9. 1.9 plus, oh, I'm sorry, -1.9, right? I want to put numbers close to -2. Plus 2 over -1.9 plus 2. What's going to happen to that fraction? It's still going to reduce to a 1. If I put -1.99 plus 2 over -1.99 plus 2, this is still going to reduce to a 1, which means this thing is not causing our fraction to get really, really big or really, really small like it did in our other ones, right? And these ones, what was happening when I put those numbers that were making the excluded values? They were making these really big numbers. Do you remember? So when I put numbers close to 2, it's not going to keep shooting off towards infinity. It's actually just going to get closer to whatever this is, right? This thing, though, when I put numbers close to 3, like 2.9, well, that's going to cause there to be a 0.1 on the bottom, which is going to make that asymptote, okay? So vertical asymptotes, that, you know, in essence, how you can find them is to find them by finding where the denominator is equal to 0, but the top isn't. So what do I mean by that? Well, take a look at this one. -3 would make this denominator 0, right? -3 would make this denominator 0. So, but it would not make the top 0. If I put a -3 in here, we would not get a 0. So it's creating a vertical asymptote. If I put a -2 in here, it makes the denominator 0, but it also makes the numerator 0. So not a vertical asymptote. Okay? So the short way to think about it is to find vertical asymptotes for a rational function. You're looking for where the denominator is equal to 0, but the numerator is not. Okay? Go try it out.